Here, this recording is concerned with an introduction to assignment C, which is based on hypothesis testing. So as you can see, the first page, you've got the Greek alphabet that we are all familiar with. And a list of formulas. As you can see, we have used many of the formulas there already. Median for interval, mode for interval, mean for row and group, variance, standard deviation for row and group, method 1, method 2, Spearman's, Pearson's, linear regression, the gradient and the y-intercept. So these formulas with the probability distribution, we have not done it yet, and we are going to use those two there, which are the test statistic for z-test and chi-square test in assignment C. And here you have the probability formulas. You have not done that yet. You'll be doing that in assignment D. So in assignment C, we are going to be using those two formulas for test statistic. Here they are, the z-test and the chi-square test. So these are the two formulas we're going to be using in assignment C. Now, as we said, assignment C is on hypothesis testing. Here we have a concise perspective with regards to hypothesis testing. It basically assesses the credibility of hypothesis by using sample data. So for your vocabulary, important terms that you'll be learning. Number one, what is a null hypothesis? It's a sentence or statement or claim to be either nullified or rejected or not. It is the statement of equality, so it always carries the equal sign. It is a statement that proposes that there is no statistical significance in a given data set. It is denoted as HO. So this term will be coming up a lot in this assignment. Then you have the alternative hypothesis. It's a sentence or statement or claim that is contrary to the null hypothesis. Simply said, it is an alternative to the null hypothesis. It is the hypothesis that the researcher is testing. If the null hypothesis is rejected, the alternative will be the conclusion. If the null hypothesis is not rejected, then the null itself will be the conclusion. It is denoted as HA or H1. So the alternative hypothesis is an important term that will be coming up in this assignment C on hypothesis testing. Third, you have to know what is the distribution curve. Is the curve used to set up the critical region or point and value which constitute the rule to be used to decide whether to nullify or reject the null hypothesis or not in a critical value approach. So you have what you call a critical value approach, which will be making use of the distribution curve. So for a z-test, for population mean, it is a normal curve because we're going to be doing a z-test, a type of hypothesis test called z-test, and another one called chi-square test. The distribution curve is always skewed to the right. So this sketch there is for the normal curve, for the z-test for mean, and for the chi-square curve, here it is, skewed to the right. That's the distribution curve. Now you have what you call a critical region. So that's another term that we have to learn in that assignment or that topic. It is a shaded region on a distribution curve, which is called the critical or nullification region or rejection region. In a critical value approach, if the test statistic lands in the critical region, the null hypothesis must be nullified or rejected. So you have what you call a critical region, and you have what you call a test statistic. We'll be talking about a test statistic in a while. So for the z-test for mean, the critical region, and you have to remember that for the z-test for mean, the critical region is determined by the sign of the alternative hypothesis. So it can be either on the left, right, or both sides. So I repeat, for the z-test for mean, the critical region, the shaded region, as you can see, can be either on the right or left or both sides. Remember, it follows the sign of the alternative. So if the alternative is pointing to the right, as you can see, the critical region will be on the right. If the alternative is pointing towards the left, the critical region will be on the left. And if the alternative sign is a not equal, the critical region will be on both sides of the curve. However, for the chi-square test, the critical region is always on the right. Okay? So take that into consideration. Another point that we have to take into consideration is the critical point. Another word. The critical point is a point on the x-axis of the curve that demarks the border line between the critical and the non-critical region. So the critical point will come right there. Right there will be a critical point. Okay? So please take that into consideration. Right there. It separates the critical region from the non-critical region. Then you have what you call a critical value. So the critical value is a number obtained from a statistical table to be placed on the critical point. So the critical value will come right there on the critical point, the critical value. You can use CV for the critical value. And then you have what you call a test statistic. It's a number that you have to calculate using the sample data to test the hypothesis, all right, using a formula. So take note that the hypothesis is a statement made with regards to the population. So when plotted on the x-axis on the distribution curve, that is the test statistic, when you plot it, remember the critical value will be there already, and it lands in the critical region. So if anytime the test statistic lands in the critical region, you have to reject HO. So HO will be rejected if the test statistics lands there. The critical region is the shaded region. But if the test statistic lands in the non-rejection region, you keep the null hypothesis. Okay? I repeat, if the test statistic lands in the critical region, you reject HO, the null hypothesis. But if the test statistic lands in the non-rejection region, you keep HO. You do not reject it. Okay? So these are some very important terms that you need to add to your vocabulary. Then you have what you call the p-value approach. So you'll be talking about the significance level. It's a probability value that is fixed in the initial stages of the test. Most researchers simply use 0.05. It is defined as a probability of wrongfully rejecting the null hypothesis. Rejecting the null hypothesis when it is actually true is called a type 1 error. Not rejecting the null hypothesis when it is in fact it is false is a type 2 error. The detection of an error will be detected if the test is repeated using more credible data and a different conclusion is obtained. So as you can see, if your test statistic is in the critical region, you reject the null hypothesis. If it is not in the critical region, you did not reject the null hypothesis. Then you have what you call a p-value approach, a probability value obtained from a statistical table using a test statistic. If the p-value approach is compared to the significance level, all right, in the p-value approach. So if the p-value is less than a significance level, then the null hypothesis is rejected. If the p-value is greater than the significance level, then the null hypothesis must not be rejected. So you have what the test statistic, you have what you call the critical value approach, and you have what you call the p-value approach. So the critical value approach uses the critical value and the test statistic. And the p-value approach uses the significance level and the p-value. So now you'll be making some decisions. So the decision will always be either to reject the null hypothesis if the test statistic is located in a critical region, or that's if you're using a critical value approach. But if you're using a p-value approach, you reject the null hypothesis if the p-value is less than a significance level. Now, you do not reject the null hypothesis if the test statistic is not in the critical region. That's a critical region approach. Or if you're using a p-value approach, if the p-value is greater than the significance level, you do not reject the null. So your decision is either to reject the null or not to reject the null. And the conclusion now, you will conclude with the null if it was not rejected. But if it was rejected, then you will conclude with the alternative hypothesis. So these are 11 important terms that you must know or familiarize yourself with or learn during assignment C.